Hello dear students, all of you welcome to Vidyan classes. Today we will discuss on symmetric and skew symmetric matrices. First, symmetric matrix. Definition: a square matrix capital A is equal to square bracket A ij or a close bracket is said to be symmetric if A is equal to A transpose, which implies Aij is equal to square bracket Aji. A dash is the transpose of A. Changing rows into columns and columns into rows, the matrix obtained is called transpose of the given matrix. A dash is the transpose of A. A has Aij is the element of ith row and jth column. A transpose has the element Aj. Since rows changes to columns and columns changes to rows. Now two matrices are equal, implies their corresponding elements are equal. Aij is equal to Aji, which implies A11 is same as A11. Aij is equal to Aji for all I and j. A11 means I is equal to 1, j is equal to 1. A12 is same as A21. A13 is same as A31. A22 is same as A22. I is equal to 2, j is equal to 2. A23 is same as A32. I is equal to 2, j is equal to 3. J is equal to 3, I is equal to 2. A44 is equal to A44. A41 is same as A14. Dot dot. In symmetric matrix, Aij is equal to Aji. From the definition, we have note A11 is same as A11. A22 is same as A22. A33 is same as A33, and so on. Implies this: A11, A22, A33 are the diagonal elements. Implies this: the diagonal elements in a symmetric matrix. The diagonal elements in a symmetric matrix are independent. A11 is same as A11, A22 is same as A22. This implies this: the diagonal elements in a symmetric matrix are independent. but A12 is same as A21, A13 is same as A31. For example, two, three, three, two, three, five is a square matrix of order 2. It is the element of A12. A12 will be same as A21. It is the element of first row and second column. It is the element of second row and first column. The diagonal element, we can take any element in the diagonal. Diagonal means left up to right bottom. But this depends on this. A12 is same as A21. Implies A is a symmetric matrix of order 2. A symmetric matrix is a square matrix. Example 2. Capital B is a symmetric matrix since it is the element of first row, second column. A12 will be same as A21. It is the element of A21. A12 is same as A21. It is the element of first row, third column. Will same as the element of third row and first column. This is same as this is same as this. The diagonal element, we can take any element in the diagonal. It is the element of second row, A second row and third column, which is same as A 3, 2. That means element of a third row and a second column. This depends on this depends on this depends on this. But the diagonal elements, that is A11, A22, A33 are independent. Implies B is a symmetric matrix of order 2. Similarly, example 3. Capital C having elements 3, 4, 5. It is the element of first row and second column. Will be same as element of A. It is A12. Will be same as A21. That is equal to 4. It is the element of 4 is the element of second row and first column. The diagonal elements are independent. We can take any element that is equal to any number, that is 8. Suppose it is 6. It is the element of It is the element of first row and third column will be same as it is the element that is A31. Sorry, A13. It is the element of first row and third column will be same as A31. A13 will be same as A31. Though in every cases the first row changes to first column. 2 3 changes to 2 3 in first row changes to first column. AHG changes to the first column, that is AHG. 3 4 5 3 4 5. It is the element of first row third column. It is the element of a third row first column. It is the element of second row third column will be same as the element of third row second column, that is 6. A23 is the same as A32. The diagonal elements are independent. We can take any number in the diagonal element. That is, suppose it is 9. Implies this C 3 4 5 4 8 6 5 6 9 is a symmetric matrix of order. Clear? Another example, D 1 2 3 4. In every cases, row 1 changes to column 1. 1 2 3 4. 1 2 3 4. The diagonal elements are independent. 1, suppose it is 5, it is the diagonal element. 6 7. It is the element of second row and third column will be same as A32. It is the element of a third row and second column, which is same as 6. It is the element of third row second column. It is the element of second row fourth column will be same as the element of fourth row and the second column. It is 7. It is the element of fourth row and the second column. The diagonal element, we can take it 8. It is 8. Suppose it is 9. It is the element of third row and the fourth column will be same as A43. That means element of fourth row and the third column. It is fourth row and the third column. This is same as this. It is the element of fourth row, third column, and the diagonal elements are independent, so we can take it. It is suppose 10. Implies this D is equal to 1 2 3 4 2 5 6 7 3, 6, 8, 9, 4, 7, 9, 10 is a symmetric matrix of order 4. Is a symmetric matrix. In every symmetric matrix, the first row changes to first column. All elements in the diagonal are independent. We can take it. And Aij satisfies Ji for all I and j. Clear? Clear? Okay, note down. Next, skew symmetric matrix. Definition: a square matrix capital A is equal to square bracket Aij or close bracket is said to be a square matrix capital A having element Aij is said to be skew symmetric if A is equal to negative of A transpose. A square matrix capital A having element Aij is said to be skew symmetric if A is equal to negative of A transpose. That implies square bracket Aij is equal to negative of Ji. Since A dash is the transpose of A, rows changes to columns and columns changes to rows. It is the element of ith row and jth column. A dash contains the element Ji. Since rows changes to columns and columns changes to rows, which is same as square bracket minus Ji. Since A into Aij is same as Aij. Whenever a scalar is multiplied with a matrix, it will be multiplied in any element of the given matrix, which implies this matrix is same as this matrix. Two matrices are equal if their corresponding elements are equal, implies Aij is equal to negative of Ji. This is same as this, which implies A11 is equal to negative of A11. I is equal to 1, j is equal to 1. Aij is equal to negative of Aji for all I and j. I equal to 1, j is equal to 1, which gives A11 is equal to minus A11. Implies A 2 times of A11 is equal to 0, that implies A11 is equal to 0. A12 is negative of A21. A13 is equal to negative of A31. A33 is negative of A33. Since I equal to 3, J is equal to 3. Which implies 2 times of A33 is equal to 0. That implies A33 is equal to 0. Clear? Similarly, A23 is equal to negative of A32. A22 I equal to 2, J is equal to 2. A negative A22, which implies 2 times of A22 is equal to 0. That implies A22 is equal to 0. From the above discussion, we have A11 is equal to A22 is equal to A33 is equal to A44 and so on. That implies now we have is equal to 0. Implies the diagonal A11, A22, A33 are the diagonal elements. The diagonal elements in a skew symmetric matrix. The diagonal elements in a skew symmetric matrix all are 0. The diagonal elements in a skew symmetric matrix all are 0. Since A11 equal to 0, A22 is equal to 0, A33 is equal to 0. But Aij is negative of Aji. A12 is negative of A21. For example, all diagonal elements are 0. 0, 5. It is the element of first row and second column. A12 will be negative of A21. So it is since it is A21. It is the element of second row and first column. Implies 0, 5 minus 5, 0 is a skew symmetric matrix. Clear? Second example, suppose B 0, alpha, beta. It is the element of first row and the second column. It is A12. It is A12. A12 is negative of A21. That is minus alpha. It is A13. A13 is equal to negative of A31. It is minus of beta. It is A13. It is A 2 1. This element is A 3 1. A 1 3 is negative. A 1 3 is beta. A 3 1 is minus beta. All diagonal elements are 0. Suppose it is gamma. It is the element of second row, third column. It is the element of third row and the second column. It is minus gamma. So the diagonal element all are 0. Implies B 0 alpha beta minus alpha 0 gamma minus beta minus gamma 0 is a skew symmetric matrix of order 3. Clear? Last example. Capital C is a matrix having elements. It is 0, 1, 2, 3. It is the element of first row and it will be minus 1. It is the element of first row and second column. It is A 1 2. It is negative of A 2 1. It is the element of A 2 1. It is the element of it is minus 2. It is the element of A 1 3. Element of first row and the third column. It is the element of third row, first column. It is the element of first row, fourth column. It is the element of that is minus 3. It is the element of fourth row. First column. Clear? Since Aij is negative of Ji, all diagonal elements are 0. Suppose it is 4, it is 5. It is the element of second row and third column. It is the element of second row and third column. It's minus 4 is the element of third row and the second column. It is minus 4. It is the element of second row, fourth column. Minus 5 is the element of fourth row and second column. All diagonal elements are 0, so it is 0. Suppose it is 6. It is the element of A 3 4. Element of third row and fourth column. Minus 6 is the element of fourth row and the third column. And the last element that is equal to 0. Implies a C 0, 1, 2, 3, minus 1, minus 1, minus 2, -3, 0, 4, 5, -4, 0, 6, -5, -6, 0. Here is a matrix, is a skew symmetric matrix of order 4. Order 4. 0, 1, 2, 3. It is 0, -1, -2, -3. Since Aij is equal to negative of Aji. -4 is the element of dash. It is the element of A32. It is the element of this. It is the element of dash. It is the element of 5 is the element of second row and fourth column. It is the element of fourth row, second column. It is the element of A34. It is A43. Clear? Since Aij is negative of Aji for all I and j, and this implies the diagonal elements. Most important, the diagonal elements in a skew symmetry matrix all are 0. Clear? Okay. Write down.